Simplifying radical expressions. Lesson 7.5. You're watching this video with Ms.Y Cavazos. So, radical expressions. This might be a new term. You've never heard it before. So what we need to do first is let's identify a few important words to a very specific looking label, symbol. Okay, so this, what we see here, looks like a little house or however you want to think of it, that is called a radical symbol. So this house looking thing, again, is a radical. Inside of it, we call that the radicand, and this can be a number, a variable, it could be a number and a variable. Okay. Now radicals come in all sorts of roots, and that is what we call this here. Actually, we call this the index. So, index is very important. Radical is a symbol. Radicand is what we call the inside. So, I'll give you a few examples of how you're going to see this. So let's say we have the square root of 5, the cube root of 7, the fourth root of 8. As you can see, I'm naming the index. Cube means 3. Root is another word for radical, so I'll just put here root. Fourth root of 8. So why did I say squared and you don't see a 2 here? That's because usually when we work with the square root, you're never going to see a 2 there, but you should know that there is a little invisible 2 there. So today's lesson is going to be about simplifying radicals. To simplify radicals, we need to bring back something that you might have forgotten, something called the factor tree. And that's what we see here, a little factor tree. So what it is they would give you a number, because you learned this either last year or the year before. They give you a number, so here's 24. And you find the possible factors of 24. So it could be 8 and 3. And we're trying to break down these factors all the way until we get to prime numbers. So all of these are prime numbers. And as you can see, we have a list here of possible prime numbers. Those are 2, 3, 5, 7. Once we break it down all the way to prime numbers, we have to pay attention to the index, because then we're going to pair them up. So if the index is a 2, well, actually you won't see a 2. If you don't see anything here, you need to put a 2. It'll help you. That way you know that we're going to have to pair numbers in 2s. If the index is a 3, that means we have to group, I'm using the wrong word here, we're going to have to group numbers that are identical in groups of 3. Same thing if this was a 4, so on and so forth. Once we have them in groups or in pairs, we're going to pull one of them out, and it's going to be outside of the radical symbol. So here, I'm going to go back to this example. Since I have a pair of 2s, I'm going to pull that 2 out, and it's going to go outside of the square root. Then we're going to have the symbol. Whatever number did not get paired is going to stay on the inside of the radical, and that is how we will write our final answer. So let's give some of these problems a try. Simplify each radical expression. So we got to think of what are the possible factors of 12. You know, there's 4 and 3, 2 and 6. It really doesn't matter which pairs you pick. As long as we simplify all the way, we find all the prime numbers. So let's say we select 4 and 3. So this is 4 times 3. 3 is already a prime number because the only 2 other factors are 1 and 3, which really won't make a difference. We don't use 1, so we stop at the 3. However, the 4 can still be broken down in 2 other factors, which is 2 and 2. Okay, So what I'm going to do is, since if you notice, these things are kind of aligned, so these are aligned together. Here I would need to bring down the 3 to keep this aligned. So next it said to put them in pairs. Why in pairs? Because the index up here is a 2. It's called the square root of 12. So that means we got to pair them up in 2s. So there's a pair. The 3 did not get paired. So the 3 is going to stay inside. So I'm going to put the symbol on it so I know it's going to stay inside the radical. So in my final answer, I'm going to pull out one of the 2's only, and it's going to go outside the radical. The 3 is going to go inside the radical, and that is how we would write our final answer. 2 square root of 3. So, how can you verify if you did this work correctly? Easy. Type this into your calculator. Type in your answer into the calculator. And you will see that they are both identical answers. Okay, next one. We have the square root of 54. How do I know it's square root? Because again, there is an invisible 2 up here. Otherwise, you would have seen a 3, a 4, a 5, so on and so forth. So we need to think of 2 factors to start off with that can multiply to give you 54. If you get stuck on how to start, use your calculator. Do 54 divided by 2. And that is 27. So that means that 2 times 27 will give us a product of 54. 2 cannot be broken down into factors. However, 27 can. With 3 and 9. 9 can be broken down because 3 is already a prime, and we find all our prime factors already. Again, these 2 are aligned. We're missing something here, and we're definitely missing information here. So what I'm going to do is bring down all these numbers, bring down the 2, bring down the 3. Next thing is circle the pairs. So here we have this pair. Or if you want to circle those 2 in the middle, it really doesn't matter. So in the end, we have a pair of 3's. 2 did not get paired, so it goes inside the radical. This 3 did not get paired, so it goes inside the radical. So in our answer, again, we're going to write the 3 outside only once. We need the radical symbol. The 2 is going to go in there, but so is the 3. Now, what do you do with these 2 numbers? Because it's not 23, it's 2 times 3. So our final answer will be 3 square root of 6. Let's try another example. 81. 81. Factors of 81. It can be any factor that you can think of. 99. 9 can be broken down to 3 and 3. This 9 could also be broken down to 3 and 3. Go back and think, okay, what was my index? My index is a 2 because it's not there, so we write it there. That means pair them up. Now, in our final answer, we pull out the 3, only once, and we didn't have any leftover prime numbers that did not get paired. You're probably thinking, Miss, what about the 9s? Well, those don't count because we simplified them. So here we have 3 and 3. We multiply those 2 numbers, and we really don't need that symbol anymore. So our final answer is 3 times 3, which gives us a simple 9. So the square root of 81 is a 9. Next we have the square root of a negative 30. Watch out for that negative. Super, super important that you notice it, because we can even break this down into factors. Our answer is no real solution. Nothing else we can do. And once you get to Algebra 2, you'll learn why the answer is no real solution. And what can we do about it? Because we can do something about it. But for right now, we're not worried about it. Okay, so here we see something different. There is a tiny 3 here, and remember that is the index. So our index is a 3. So the way we pronounce this is the cube root of 250. So we're going to start off the same way. Find all the prime factors that we can for 250. So how do we start? If you don't know how to start, divide this number by 2. Let's find out if that works. So 250 divided by 2 is 2 and 125. 2 cannot be broken down into prime factors other than 1 and 2, so that doesn't count. So 125. If you divide 125 by 2, you're going to get a fraction or a decimal. So what if we divide it by 3? Again, fraction or decimal. By 4. If you notice, it ends in a 5. So if we divide by 5, we get that 5 and 25 are 2 factors. 25 is already prime, so we're going to focus on the 25 and break that into 5 and 5. So before I start circling groups, I'm bringing everything down. And remember, the index is a 3, so that means we're going to have to group in 3s. So all these 5s belong in one group, and there's 3 of them. This 2 does not belong to a group. So it's going to get stuck inside the cube root. So in our final answer, we write the 5 outside only once. We're going to need this with the 2 inside, and don't forget there is an index of 3. And that is how we write our simplified answer. Next we have this really large looking number. So if you pay attention to the number, you notice it ends in a 0. So if we divide this by, let's start off with 10. It's a pretty large number, so you don't want to start off with 2 or we'll never finish the factor tree. So 10 is a factor. 10 times 432 are perfect. 10 can be broken into 5 and 2, and that's as far as we go with that. So 432. Next we have to think of what factors could we use, because we could use 2 and 216, 4 and 108, 8 and 54. It's really up to you, it doesn't matter. We could use 4 and 108, so 4 and 108. 4 of course can be broken down to 2 and 2. 108 will have to be broken down by 6 and 18. 6 can be broken down by 2 and 3. 18 we could use 3 and 6, and 6 can be broken down by 3 and 2. As you can see, this factor tree can get pretty lengthy. So we're going to try to bring all of these down so they are at this level here. So that way we can focus on what are we supposed to pair. So bring down that 3, and everything is multiplying. Bring down this 3, bring down this 2, this 2. Now remember, there is an index that is not a 2, it's a 3. So that means group them in 3s. So here we have, there's a group, there's a group, there's 2 2s, but I need a third 2 to make it into a group. So I mean that stays inside, that stays inside, and that stays inside. So in our final answer, we're going to put the 2 only once outside, the 3 only once outside. We're going to need the radical with the index of 3. 5 goes inside, 2 goes inside, and this other 2 also goes inside. So what we do with all these numbers is we're going to multiply them. So this becomes 5 times 2 times 2, which gives us 5 times 2 is 2 times 2 is 20. And between these two groups, 2 times 3 is 6, and that is how we would write our answer in simplified form. Next we have variables. What do we do when there's variables? Easy. How many x's do you see here? Or how many x's are they telling you that there are? There's 7 x's. So I'm going to break this up into literally 7 x's. Pay attention to the index. There's nothing there, so it's assumed automatic 2. So what we do is we're going to pair these up. There we go. Pair, pair, pair. Not a pair, so this stays inside. So we had a pair of x, so I'm going to write it once. ones, inside the radical. Now there is another way of writing this answer in simplified form. So how many x's do you see outside? 3. X times x times x times x, x to the third, with the square root of x, and that is our simplified answer. Same thing with the w. There, if we expand, we're going to have 8 w's. Put them in pairs, one pair, another pair, another pair, another pair. All of them were paired up. How come do we put them in pairs? Because there's an invisible 2 here. So we have that we're going to write this outside ones, and ones. So we put them in total, we have 4 w's, so our final answer is w to the 4th. Next we have y, the cube root of y to the 11th. So I'm going to expand. I have 11 y's, and I'm going to put them in groups of 3 because that is the index. So it's 1 group, 2, 3. These did not get grouped, so they stay inside of the radical. So then we have y, another group of y, another group of y, and 2 y's that did not get grouped. So in the end, we can rewrite y times y times y as y to the third with the cube root, and I forgot to put the index of 3, y squared, because there's 2 y's inside the radical, and that is how we write our simplified answer. In this next problem, we have a coefficient and variables. So we have a value of 80 and then n to the third. We're going to simplify. We're going to find the factors of 80, and we can use 10 and 8 because, well, that works. Break down the 10, and that's 5 and 2. Break down the 8, and that's 4 and 2. Break down the 4, 2 and 2. Don't forget to bring down the n. There's 3 n's, so there we go. Bring this down so everything is at the level of the last prime numbers. Next, we need to remember what is the index here. There is a 2, so that means put them in pairs. So those two go together, those two go together, that goes together. Whatever did not get paired goes inside the radical. So in our final answer, we have 2 times n, square root of 5 times n. So our final answer is 2 times 2 is 4, so this is 4n, square root of 5n. And that is how we write this in simplified form. Next problem, I'm going to find the factors of 144, and I can use 4 times 36, break down the 4 and the 36. Okay, so the index is 2, so that means here's a pair. Here's a pair of 3's. They're not next to each other, but I can still pair them up like this. I also have another 2, so I can pair them up like this. My r's, here's a pair, here's a pair. There's only one thing that did not get paired out of everything, and that's this r over here. So in our final answer, we have a 2 times 3 times a group of 2 times a group of r, or a pair, another r, and then finally the square root of r. So our final answer, we can write it as 2 times 3 is 6 times 2 is 12. There's 2 r's, so r squared, and the square root of r. And that is our simplified answer. Next problem. Break down the 100, find the factors. Okay, 10 and 10. Break up the 10s, 5 and 2, 2 and 5. The index is 2, so I'm going to put them in pairs. Here's a pair. Here's another pair. Pair, pair. Everything got paired. So then we have 5 goes outside, 2 goes outside, H and H, because there were 2 groups, 2 pairs. 5 times 2 is 10, H squared. And this is our simplified answer. Next example. If you notice, there is a coefficient. There is a number in front of the radical. So what I'm going to do is put parentheses around it, so I can focus on the radical 54. That means we're going to need to break down the 54. I'm going to use 6 and 9. So 6 and 9, 3 and 3, 2 and 3. Now, this is inside the radical, so we're not worried about the 2 yet. The radical has an index of 2, so there's a little 2 there. So that means pair them up. That's the only pair that we have. So that pair goes outside. This 2 and 3 stay inside the radical. So that means 2 times 3. But then we need to pay attention that there was a 2 in the very beginning. So then finally we have 2 times 3 we can multiply inside the radical, which is 6. And we're allowed to multiply 2 times this 3, which also gives us a 6. So we have 6 square root of 6 as our simplified form. Same thing for this problem. When there is a number out here, put parentheses around the radical and find the factors of the radicand. So I'm going to use 4 and 12 and break those up all the way until you find all the prime factors. Don't forget to bring this down to be at the same level. Okay, the index is a 2. So that means pair, pair, not a pair. So my pairs, I have a pair of 2, another 2, square root of 3. So that becomes 4 square root of 3. But don't forget that in the very beginning there was a 7. So we got to bring it down. And that just means multiply 7 times 4, 28. Keep the same radical. And that is our simplified form. Thank you for watching.